Hello and good morning. This is Craig Kozminski with your final pre-lab video. The bulk of our video today is going to focus on the nutrition sheet. This is your homework for this week's lab. And so I want to go through an example with you so that you know how to solve this for the assignment that's due in lab this week. So what you'll see here on the right-hand side is a picture of a chocolate protein shake. The brand is called Fairlife. So the source of my calories here for my Fairlife shake, we're going to break this down by uh, macronutrient. So we're going to be looking at the relative amount of fats, carbohydrates, and proteins. And so here in our Fairlife, we have a little bit of each. So I have 2.5 grams of fat. And then in my carbohydrates, I have 4 grams of carbs. And I have 30 grams of protein. So these are really, not only are they delicious, but they are also a really good source of protein. So if you exercise, then it's oftentimes good to consume a high protein supplement or diet immediately following. And so the fuel value for each of these macronutrients is included in your lecture manual. I'm putting it here for the sake of ease. So we know that the fuel value for our fats is 9 kilocalories per gram. For our carbohydrates, we know that it is 4, and for our proteins, that is 4. So what we're going to do now is we're going to calculate the number of calories that we would expect in this shake based on the number of grams of each macronutrient. So 2.5 times 9 is going to give us the number of calories from fat, and that is 22.5 kilocalories. And for our carbs, we know that 4 times 4 is going to be 16 kilocalories. And for our protein, 30 times 4 is going to give us 120 kilocalories. So this gives us the kilocalories per macronutrient. So now we're going to add them up. 22.5 plus 16 plus 120 give us a total calculated calories of 158. So if we add these up, we get 158 kilocalories. Now this is pretty close to what we have listed here on the nutritional label. Here they're only listing it as 150. So there's a slight discrepancy here. If we use the proper fuel value for our macronutrients, our fats, our carbs, and our proteins, we'll see that sometimes when we look at the number of grams of each macronutrient per serving, that we get a different calculated calories. And so what you are encouraged to do is to take a look at a few of the food items maybe that you have in your room or apartment, or if you are purchasing them at one of the stores on campus, to take a look and to do this basic breakdown. You'll be expected to submit this at the beginning of this week's experiment. Now, in the last week's experiment, we focused on the processes of photosynthesis and cellular respiration. And in this final experiment, we're going to look at community energetics, nutrition, and the life cycle. There are a few parts in this experiment. Part A, nutrition, we'll talk about in just a moment. But that part of the experiment is just going to be done on paper. Part B is we are going to be measuring the amount of production in an aquatic community. I would encourage you, if you haven't done so already, to pause the video and read through the entirety of the introduction as well as the procedure, and to take a look at the equations that we're going to be using for this week's experiment. Part 3, or part C, is that we are going to create a food chain using the food chain data table here. Note the unit. This is going to be placed in the top of the food chain. The unit that we are looking at for these numbers is kilocalories per square meter per year. All right, so here are your lab report questions for lab report number 11. Some of you are oftentimes very concerned with getting out of lab as quickly as possible. I hope it doesn't have to do with me and that rather you have somewhere to be. But I would encourage you, if you are one of those individuals, you can come to lab having pre-populated these highlighted questions. These questions are asking you to list the definition of the terms net primary production and gross primary production, as well as to fill in the number, or excuse me, the processes that we talked about in our previous experiment, which we already talked about in the beginning of this video. All right, so for part A, we're kind of going back to part A. We were asking you to record your total number of calories consumed over a period of 2 days. Okay, so total calories for one day, total calories for day two, and to find the average of your calories consumed over those 2 days by dividing that number by two. You can then go ahead and calculate what is called your presumed basic metabolic rate. This would be the number of calories that you are consuming, your body is consuming, by way of your height, your weight, and your age in years. And then what you can do is calculate your total metabolic rate by taking the TMR, dividing it by the BMR, and multiplying it by 100. This is the extent of our part A of our experiment. Next up, you'll see the calculations that we're asking you to conduct for part B of the experiment, the community energetics, the amount of production that's occurring in pond water that has a contingency, of algae, which is going to be undergoing some amount of photosynthesis and some amount of cellular respiration. Finally, our food chain or life cycle, we'll get you started with this on the day of your lab, but it's probably best that you don't start on this before lab, and if you do, be certain to use a pencil. So I hope this last pre-lab video is helpful to you in easing your anxieties and preparing you for this week's experiment. And as always, if you have any questions, please reach out to your lab instructor.